So let's go through some of the different ways you can attempt to solve the problem. So you have packet analysis, which is typically using Wireshark or a sniffer to try and analyze the packets. You have application performance monitoring as another take on how to solve this problem. And you also have traditional NPM solutions with SNMP. Let's go into each of these with a little bit more detail. So starting off with packet analysis, you have a packet analyzer set up on a span port on a switch. This could be on a tap, this could be on a hub, really anywhere in this environment you can put that packet analyzer. So as far as trying to analyze what's going on, you have the PC transmit a packet. The switch will then say, I need to transfer this packet out to the router and also send a copy to the packet analyzer. So this packet goes both these directions. The router then sends that packet on its way, and let's say it gets dropped at this location. At this point, the packet analyzer has no concept that the packet was dropped, so it has no awareness of this. So depending upon where your sniffer or your Wireshark is plugged in, you're not going to see the packet loss. Now, if you have a more advanced packet analyzer, what's going to happen is the server at the far end is going to say, hey, this is a TCP connection, we're missing a packet. It's going to end up sending a retransmit request back to the client, and the packet analyzer is going to get a copy of that. At that point, the packet analyzer knows, hey, there's something that needed to be retransmitted. Now, this only happens if you're looking at both directions and you have a packet analyzer that's smart enough to put the pieces together to say this retransmit was a result of the fact that that packet was missing. Then what happens is your PC transmits the retransmitted packet. That retransmitted packet also goes to the packet analyzer, and the packet analyzer says, here's the matching problem. So again, if you have the smarts inside that packet analyzer, it can put the pieces together. Now, what is the packet analyzer able to do with this? What it's able to do is simply confirm that you have a problem. It doesn't know where the packet went missing or why. It just knows that there was a missing packet. Now, it only does this if it's TCP, because TCP will do the retransmit request, have the retransmitted packet. If it's UDP, there's even no awareness of the loss. So a packet analyzer really isn't very useful for troubleshooting real-time protocol problems because there's no retransmit. Now, you could move the packet analyzer around, or if, let's say you had 8 different packet analyzers all over your network copying packets, then you might be able to use that to help narrow down where the packet loss might have occurred. But it gets really complex at that point because they're having to synchronize to say, we saw the packet here, we saw the packet here, we didn't see the packet over here, so it must be lost between these 2 points. Typically, people don't have 40 different packet analyzers all over their network collecting from different positions, so it just makes a bit of a mess. So packet analysis isn't really the best way to solve this problem. So let's move on to APM. So APM, application performance monitoring, what that is you set up a software agent on a computer, set up another software agent, and you run test packets between those two. So those test packets are going to end up having notification packets that respond to say, here's what we see. So it sends out a test packet, it sends out a second test packet, sends out a third test packet that gets dropped, and a fourth test packet that makes it through. It's going to send back a notification saying, hey, we found 25% loss between these 2 agents. That's as far as you get with APM, is confirmation that there is a problem between these 2 agents, but no understanding of where or why the packets were lost. Now, depending upon how many agents you have, if you set up 40 different agents around, that might be able to help narrow down, again, where the problem is coming from and why, but you have to have a lot of these agents pre-set up to be able to do these types of tests. Something also to consider is, if you have a bandwidth limitation or you're talking about a resource limitation, these APM tests can exacerbate the problem because during your testing period, this is going to make it worse for all of your actual users because it's like during a rush hour congestion, you're putting 400 extra cars on the road just to test to see how long it takes to drive to work. And that can make things worse. So you have to be careful with APM in this circumstance. So the third method is traditional NPM solutions using SNMP. So you end up having inbound errors and outbound errors tracked on various interfaces in your environment. And typically it's just trunk ports, router interfaces. So it's a small handful of interfaces that this information is tracked on. You end up sending the packet, it goes through the switch, it goes through the router, it then gets dropped. Okay, so what does your NPM solution know about? Well, if you go check the error counters, it's going to say, gee, it sees no inbound errors, outbound errors here, no inbound errors or outbound errors here. This looks healthy, and also this looks healthy. So at this point, it's saying, gee, it doesn't see any errors, so it's not going to help you solve the problem. Now, if you were able to look deeper and look at the server as well as deeper at these error counters, you might actually determine that this one interface on this switch actually has a pile of FCS errors. So really the trick here is that the clues are all hidden inside of SNMP throughout your entire infrastructure. So I'm going to now show you how you root cause solve this problem with total network visibility. So what PathSolutions is designed to do is install and then rapidly scan your network, finding every switch, router, gateway, and firewall, and we're going to query all those devices as well as every interface on all those devices. You're responsible for the entire network. You thus should have visibility that matches your responsibility. So we're going to make sure you know what's going on throughout the entire network. The second thing is that your network equipment is incredibly smart. There's all sorts of error counters, configuration, performance information that average network monitoring software just doesn't even pick up. So we decided to dig deep, and no matter what make, model, or manufacturer, we're going to get all the performance, the configuration, 19 different error counters, all the QoS, CDP, PoE, all of this connectedness. We're going to get all of this information off these devices, pull this back, and then put it through a heuristics engine. The heuristics engine produces plain English diagnostics of problems that we find in the network. Thus, within an hour of deploying our software, we're going to tell you everything your network equipment knows because we're able to ask it for what are the problems. We can tell you about cabling faults, microburst link floods, CPU utilization spikes, VLAN tagging faults, duplex mismatches. So any sort of problem that your devices are aware of, we're able to automatically glean that information and root cause troubleshoot it so that you can start proactively fixing the problems in your network. Now, our core package also has the ability to do path mapping. What this means is it's going to make troubleshooting even easier and more automated. If somebody said they had a call quality problem between a PC and another server or packet loss or slowdowns, you just put those two IP addresses in and it's going to path map between those two IP addresses, showing you every link, every switch, every router used to connect those two, and what happened along that path during any point in time during the day. That way, if somebody said they had some strange disconnects at 2:30, you just run the path map report, look at it, and say, oh, we have a cabling fault connecting to that server. Let's go check that fiber connection. Maybe we need to clean the ends off of it. Or we have problems with a high priority queue that was destined for that traffic, and it's dropping packets out of that queue. That should be a high priority data traffic. So it gives you the ability to see what happened along that path for every involved link, switch, and router involved. So the core package includes everything needed to run a perfectly healthy network. So this isn't just one point solution. It's going to solve all of your network problems because we'll have diagramming, path mapping, port mapping, server monitoring, inventory, cloud service monitoring, MIB browser, NetFlow, and configuration automation. So I'm going to go into a quick demo and show you how we can make it easy to solve a packet loss problem in your network. So you deploy, it's going to rapidly scan through your network, and it's going to find all of your switches, routers, gateways, and firewalls, and immediately start picking up information from them. As it picks up information, it's going to be analyzing the information to say, here's what's broken. And by the way, you have something broken on the Syrah switch. Okay, let's investigate this. We click into the switch, and we're going to see, here's all the interfaces on the switch. Looks like interface 5 has a problem, and 4% packet loss. Now, if I told you that we had 4% packet loss on a switch port, you might say, well, so what? It's probably a printer. Maybe it's a photocopier. I don't care. But if it's a trunk port to another switch, or there's a critical server connected there, or there's some critical voice device there, then that is a high priority problem. So to help identify what is affected by this packet loss, we expose all of the CDP and LLDP information so you can see what's connected upstream. We also have a fully integrated port mapper. Click on the Connected tab, and it's going to show what's plugged into each of these interfaces. This interface has one MAC address, so it's not a trunk port to another switch. The MAC address associates with the HQ voice VLAN, VLAN 110. We have the MAC address, the manufacturer of the device, the IP address, and the reverse DNS record. Okay, so this is our voicemail recording server. Now that we recognize this is a high priority voice server, the packet loss here is definitely a problem that needs to be solved immediately. Let's go see what the problem is. I click into the interface and we immediately see the utilization graph. Below that, we see the packet loss graph. And then below that, we see the plain English prescription. And here we're being told we have a cabling issue. So it's that fast and easy to recognize we have a problem on the Syrah switch. We have a problem with interface 5. The problem relates to packet loss. The problem affects this voicemail server. Here's what time the problem started. Here's what time the problem stopped. And here's what the problem is. So we have complete awareness about it and can get it resolved. Now, something to recognize is that other monitoring products wouldn't even be aware of this problem because they're not looking at every interface. Even if they were looking at this interface, they still wouldn't be aware of it. Here's why. If we go up to the error counters, we can click on View Error Counters, and it's going to show us all 19 of the error counters that we're picking up and analyzing. Other monitoring products, if they're looking at an interface, they're only going to look for inbound errors and outbound errors. Thus, they're going to mislead you and say that this interface is healthy. We're going to say, no, sorry, the truth is you've got a ton of FCS errors, you've got some deferred transmissions, and some outbound discards. So because we go deeper, we get more of the truth of what's going on. Then we put together all of these error counters with our heuristics engine to analyze the presence of the error counters, the absence of the error counters, the interface type and configuration to come up with a plain English prescription. That way you get problems solved quickly because it's been pre-analyzed by the solution to be able to say, here's what you need to do to fix it. Now, if you want to learn more about these error counters, we have a built-in engineer's library. Click on the error counter, and it's going to give you the official IEEE definition, a more basic lay definition, and then all of the different causes as to where the problem can come from. That way you don't need to go out and search Google or Wikipedia. It's going to have all the information brought to bear so that problems get solved quickly. Now, something to recognize is that with all of these error counters checked on every interface of the network at every 5-minute period, what that means is if you drop or buffer even a single packet anywhere in the network, any point in time for any reason, we know about it. Now, let's put this together and do a root cause troubleshoot between two IP addresses. I go to the Path tab, and let's say we have a user that said, just before noon, they had a really bad unified communications connection. Can you help solve it? Well, yeah, here's how fast it is to solve it. I'm going to put in the IP address of their computer, put in the IP address of the gateway they're connecting to, and click Map. What this will do is analyze every link, switch, and router used between those two IP addresses by analyzing the routing tables, bridge tables, ARP cache, and spanning tree to say, here's how these two devices talk. There are no agents needed. We're analyzing the routing tables and bridge tables to say this is how your network connects these two. So this is something that you can have available within the first hour of deployment. So here's the PC. Looks like it's connected to the Pino layer 2 switch and connected to interface number 7. That interface over the past 24 hours looks perfectly healthy, especially around noon when the user said they had the problem. Now, when we say an interface is perfectly healthy, we mean perfectly healthy according to all 19 error counters. Other network monitoring systems, if they say an interface is healthy, sadly, you could have collisions going on and just we wouldn't know it. And it would say it's healthy when it's actually not. Outbound on the Pino switch, it's going out interface 25. And that interface here looks like, well, there's some high utilization around noon, but there's more bandwidth available and no packet loss. So that's a perfectly healthy interface. Let's keep looking. Inbound and outbound on the Syrah switch looks good. Uh-oh. Outbound on the Burgundy switch, going out interface number 3, we look at that interface and say, gee, looks like at 11:52 a.m. we were dropping 6% of the packets. So this is a suspicious interface. At this point, we click into the interface, we read the plain English prescription, and we get the root cause of the problem resolved because we found where the packets were being lost and why, because we're looking deeper and broader into the network, and we have all of the analytics to put it together to make it easy to root cause solve a packet loss issue. So there's additional modules that we have available if you're looking to solve telecom problems. We have the ability to do call simulation. We have full visibility into QoS queues. We can do SIP trunk troubleshooting. So if there's a problem outside of your network, we can help troubleshoot that as well. We can locate phones and alert on MOS scores. We have a full security module that includes all sorts of capabilities that will improve your security posture on the network by giving you the ability to rapidly respond to security events, monitor communication policies, device OS vulnerabilities, geographic alerting. And we also have a work from home module. If you need to help support folks who are working from home and they're saying, hey, they're having problems with meetings, you can't make a site visit out there, but we have a software agent that you can deploy, and it's going to be able to do a root cause troubleshoot, and the user doesn't have to be technical at all. You can end up getting all of the technical information brought back to be able to tell the user, hey, you have a firewall issue, or you're having some wireless performance issues because there's too much channel contention in your neighborhood. So you have all of that ability to do a root cause troubleshoot for work-at-home users. If you want to learn more about the solution, please visit our website, www.pathsolutions.com, or you can email sales@pathsolutions.com and they can help set up a more in-depth demo of our solution so you can see how it can help solve problems in your environment.